So the last thing we're going to look at when working with redox reactions is how to balance them. In redox reactions, we need to make sure that not only the number of atoms is balanced, but that also the charges are balanced. So in this reaction, we have magnesium plus an ion of iron gives us a magnesium ion plus iron. So, as we know, when assigning oxidation numbers, if it's a free element by itself, its oxidation number is 0. The only reason our iron and our magnesium aren't 0 is because they've already been assigned oxidation numbers or charges because they're ions. So now, as we've been doing, we connect our like with our like on either side of the arrow, and our magnesium is going from a 0 to a positive 2. So we know that it is losing 2 electrons. Our iron is going from a positive 3 to a 0, so we know that it is gaining 3 electrons. Now to balance the charges, all we have to do is swap the 2 and the 3. So to do that, we're going to multiply each of these by the other charge. So our gain 3 of electrons, we're going to multiply by the number of electrons lost by magnesium. So we're going to multiply this by 2. Down here, we're going to multiply this by 3. And we're going to make these multipliers our coefficients for the corresponding elements. So this 3 is going to become the coefficient on both of my magnesiums, and this 2 is going to become the coefficient on both of my, let's make sure it's the correct coefficient. It's going to become the coefficient on both of my irons. The final step in balancing this equation is to make sure that not only my charges are balanced, but that the number of atoms are balanced. So on this side I have 3 magnesiums, over here I have 3 magnesiums, over here I have 2 irons, and over here I have 2 irons. And now to double check my charges, I have 3 times 0 is 0, and 2 times plus 3 is a positive 6. So I have a positive 6 charge on my reactant side. Over here, 3 times positive 2 is 6, and 2 times 0 is 0. So over here I also have a positive 6 charge. So my charges are balanced and my number of atoms are balanced. So now let's take a look at one more example. So first I need to check and assign my oxidation numbers. So my copper over on my reactant side and my aluminum on my product side both already have their oxidation numbers assigned. And when you need to balance a redox reaction, you're going to see it in this format. So an element plus an ionically charged element on our reactant side plus another is going to give us an element plus an ionically charged element on the product side. You're never going to have compounds on your reactant side or compounds on your product side. It's always going to be broken down into individual elements, and you will be given the charges for the ions. So all you need to do is for the elements that don't have an oxidation number assigned, you need to assign a 0 oxidation number because they are free elements, they're by themselves. So now we connect like and like, so our aluminums and our coppers. So our aluminums are going from 0 to plus 3, so they're going to lose 3 electrons. My copper is going from plus 2 to 0, so it is gaining 2 electrons. And now we simply swap, and we'll use a different color for that. We simply swap. I'm going to multiply this one by 3, since my aluminum is losing 3 electrons. And this one I'm going to multiply by 2, since my copper is gaining 2 electrons. And then my multipliers are going to become my coefficients. So 2 for both of my aluminums and 3 for both of my coppers. And now I make sure, so my aluminum, I have 2 aluminums over here, 2 aluminums over here, 3 coppers over here, 3 coppers over here. Now to check my charges, 2 times 0 is 0, 3 times positive 2 is 6. So I have a positive 6 charge over here. Over here, 3 times 0 is 0. 2 times positive 3 is positive 6. So over on my product side, I also have a positive 6. So my charges and my number of atoms balance. Now let's look at one final example. So I'm going to assign my oxidation numbers. So my chlorine is 0 because it's by itself. My iodine has already been assigned to -1. My I2 is 0 because it's just two iodines bonded together, and my chlorine over here has already been assigned as -1. So I connect my chlorines together and my iodines, and I see that my chlorine is going from 0 to -1, so it is gaining 1 electron. And up here my iodine is going from -1 to 0, so it is losing 1 electron. And now, if I multiply these, I multiply this by 1 and this by 1, I notice that none of my coefficients are going to change, because I would just be putting a 1 in front of each of these. So my charges are already balanced, but before I finish, I need to check and make sure that my number of atoms is balanced. And as I can see over here, I have 2 chlorines, but only 1 chlorine over here. So I actually need to change this coefficient to 2. And then over here, I have 1 iodine over here, but 2 iodines over here. So this coefficient needs to become 2. And if I check, I've got 1 times 0 is 0. Over here, 2 times -1 is a -2. And over here, I have 1 times 0 is 0. But 2 times -1 over here is also a -2. So by balancing the atoms, it kept my charges in balance. So now, finally, my atoms and my charges are balanced. So after you balance your charges, make sure that you go back and check that your atoms are balanced as well. And if they're not, you need to rebalance the equations so that they are. Balancing your electrons, balancing your oxidation numbers and your charges gives you a jumping off point. It is not the end point. You always need to go back and check to make sure that your number of atoms are balanced between your reactants and your products as well. And once you balance that, it should take care of your charges as well.